past 32, but I want to look back at problem number 32 before we look at solving. Okay. Yeah, you can go get it. I did add a file to the Google Classroom because earlier I just went through and did the whole review sheet myself and scanned it and uploaded it, so it's all up there if you want to look at it. But yeah, I went on and hand wrote 32 is what we're looking at. Hand wrote out all the review sheet, even the ones that we're not going to be on the test, and went on and just uploaded it to the Google Classroom. So if you wanted to go back and look at it, you can. I did condense a few steps here and there, but it's all there, all written out. So thought it might be helpful to have if you wanted it. Don't have to. But 32, we're looking at f plus g of x first. F plus g of x is the same as f of x plus g of x, which for us is 4x to the 5/4 plus 2x to the 1/2. Well, we can drop the parentheses. And then we can combine like terms. And what are our like terms for this here? Well, x to the 5/4 and x to the 1/2, are they the same? Are they like terms? No. Now we're going to look at f minus g of x, which is f of x minus g of x, and we can plug the functions in. Yeah.
No, I think you can come back. No, I gotta get it for free. Probably before it goes around.
If they aren't like terms with addition, they're not going to be like terms with subtraction. All right, guys. Focus in here. So f times g of x is the same as f of x times g of x. So we have 4x to the 5/4 times 2x to the 1/2. Multiplication, 32. Now we can multiply our 4 into first. 4 times 2 is 8. Now when we multiply like bases, we add the exponents. So we'll have the 5/4 plus 1/2. Now we can do that in a calculator. I'll clear all that out. 5/4 plus 1/2 is it'll be probably Tuesday or Wednesday. Most likely Tuesday. Questions on addition, subtraction, or multiplication? We ready to look at division? We'll see. You're good. Is 33 our f plus g of 2, f minus g of 2, f times g of 2? Yeah, we skipped those. No, it's not that they're any harder. It's just time consuming. Because you'd have to find f plus, well, you can do f of 2 plus g of 2. You plug the value of 2 in and simplify from there. So it's just tedious more than anything else. Yeah. I would not eat anything off this floor. Because well, I will say that that wall is still, the carpet's still damp from 2 days ago, or or yesterday, from when. Yeah, that was where the boys' bathroom flooded.
Oh, nice. Oh, that's great.
Yep. So.
That's not.
Now, division. So f of x divided by g of x, 4x to the 5/4 divided by 2x to the 1/2. We'll do 4 divided by 2 first. If it doesn't divide evenly, leave it as a fraction. In simplest terms, when we divide like bases, we subtract the exponents. Now again, 5/4 minus 1/2, we can do that in the calculator. Let it do it for us. And we would get 3/4. So f divided by g of x is 2x to the 3/4. Now if the 4/2, if it was something that didn't reduce, you can put the variable either on top or next to it. Just don't put it in the bottom. Questions on 32. You feel good about 32? 33, 34, doing this with a number is not going to come up. We're not going to focus on those. And I believe we got through 35 through 41. We did those. Yep. 44, solve the equation and check your answers. Now, on the test, there's going to be 4 solving with radicals. 4, you will need to check your answers, and it will say, I think in all caps, check your answers. If it just says solve the equations, you don't have to check it. But if you feel like the answer is not right or doesn't look like it's right, go on and check it, just make sure. And go from there. Now the first one, number 44. Is there one, if there's one radical, get it by itself. Here there's one radical and it's already by itself. Step 2, put both sides to the nth power. And our nth power is 2. So here the radical and square will cancel. Telling us 2y is equal to 64. 8 squared is 64. Now we need to solve for the variable. We would divide by 2. Telling us y is equal to 32. Now if it asks to check your solutions, go on and check them. You don't have to write check. But all you're doing is going back and plugging each of your solutions back into the equation. Now the right-hand side is 8, left-hand side 2. Square root of 2 times 32. Square root of 2 times 32 is square root of 64, which is 8. So 8 equals 8. We're done. You don't have to do it step by step. You don't have to do 2 times 32 and write the square root of 64. Simplify to 8. Just plug it in, type it into the calculator, let it do the work for you. So that's all I'm looking for if it's asking for checking. Questions on this here? Does that make sense with checking? plug it in, simplify it. Make sure that both sides are equal. If both sides aren't equal, just put a line through it, cross it out, and cross out that solution. Yep. 45. There is one radical, so we need to get it by itself. The square root of y minus 4 is equal to 8. Since the radical is by itself, we now put both sides to the second power. So y minus 4 is equal to 64. Solve for the variable. Add 4 to both sides, so y is equal to 68. If we check this, 68 minus 4 plus 7 is equal to 15. Now the right-hand side's nice, it's just 15. Second square root, 68 minus 4 plus 7 is also, does check out, and we're good there. Questions on these two here? We go with 44 and 45. Okay. 46 ends up being no solution. Questions on 47? Yeah. Is there one radical? If so, get it by itself. Already by itself, so put both sides to the nth power. Yeah, we're cubing it. We're putting both sides to the third power because our cubed root and third power will cancel out. Showing us 2x minus 1 is indeed equal to 8. Now we solve for x, so we're going to add 1. Showing us 2x is equal to 9. And lastly, we would divide by 2, telling us x is 9 over 2. Root. Yeah. Questions on 47? Questions on 48 or 49? 48, is there one radical? No, so we need to even them out. So we can add the 9th root of 4x to both sides. Those cancel. So I mean that the 9th root of 2x minus 1 is equal to the 9th root of 4x. On this one here, really, you end up equal them out. I crossed the 0 out and set them equal, because that's essentially what happens. Now that they're evened out, we're going to put both sides to the nth power. Because on the left-hand side, our 9th root and 9 cancel, and they just cancel out because we don't have anything besides that root there. The right-hand side, again, you can, I would go the other way. Because we don't have x to a power, x squared. Get the variables together, get everything else on the other side. Tells us negative 1 is equal to 2x. Divide by 2, telling us x is negative 1/2. That's it. We can plug it into the original problem. It'll still work. Ninth root of 2 minus negative 1/2 minus 1 minus 9th root of 4 times negative 1/2 is 0. The original equation was equal to 0. So yes, it does work. Yes. Yes. You would subtract. Mm-hmm. Yes. Because there's not going to be a no solution on the test. So that's part of the reason I'm skipping it, not because it's not going to show up. It's just because it's an even root and it's going to equal a negative, because you would subtract 27, giving us negative 23. Divide by 3, that number is still negative. It doesn't work. If it had been, say, negative 3, made it back positive, then it worked. Now, if you see 49, we have the cubed root of 10x plus 15 equals a negative. We have one radical and it's by itself, yes? Now, it's equal to a negative. So our first step would be to cube both sides. And when we cube a cubed root, those cancel, telling us 10x plus 15 is equal to negative 5 cubed. Well, negative 5 to the third power is negative 125. Now, this is part of the reason that cubics does work, is we can take a cubed root of a number and get a negative. A negative can come out of a cubed root. A negative number cannot come out of an even root. So that's the issue there. Now, from here, we can just solve. And lastly, we would. So x is negative 14. Now I can check this here, take the cubed root of 10 times negative 14 plus 15, and this should equal negative 5. Cubed root of 10 times negative 14, and then it was plus 15. Does indeed give us negative 5. Odd root can equal a negative, and even root cannot. That's why 46 did not work, because when we got the radical by itself, it was equal to a negative. We can't have that. Questions on 49? That is for 50? Yeah. That is an S.
I didn't know if that was 8, 5, or 30.
Note, S minus 1 squared is equal to S squared minus 2S plus 1. I do include something like this on the test. Now, if we look at number 50, square root of 3 minus S equals S minus 1. Well, first thing we've got to do is get the radical by itself, yes? Is it by itself? So we can put both sides to the nth power. So we're going to square it. Now on the left-hand side, our square and square cancel. Showing us 3 minus S is equal to S minus 1 squared. What is S minus 1 squared? S squared minus 2S plus 1. Now, again, I put that there just to save time for y'all so that you don't have to go through the full steps. Because if we did go step by step, it would be S minus 1 times S minus 1. S times S is S squared. S times negative 1 is negative S. Negative 1 times S is negative S. Negative 1 times 1 is negative 1. And when we combine like terms, we get s squared minus 2s plus 1. We get essentially what I gave you at the start. And then we'll get it to 0. So if you want or notice or see the fact that that note is there, and there is one there. Yeah, they're all s's. It is a very odd variable to pick. We rarely see s show up.
Is that in that circle? The s squared minus relative to 2s?
2s plus 1. Yeah, this, our note is what we got to, isn't it? So you can multiply it out and get there, or just plug it in. Yeah, s squared minus 2s plus 1 is s minus 1 squared. Well, I did give you that at the start. So you could have just replaced s minus 1 squared with s squared minus 2s plus 1. Now, indeed, we do need to get this equal to 0 because we do have a variable being squared, our s squared. Doesn't matter which one we do first. We can add s to both sides. So I just say we have s squared minus s, not 2s, plus 1. And then we can subtract 3, telling us 0 is equal to s squared minus s minus 6. Now, at this point here, we can factor. We can use the quadratic formula, or we could graph it. This is probably one of the few spots where you'll actually probably use graphing on this here. Instead of s, we're going to use x for the graphing calculator, so x squared minus x minus 2. Second graph. We're looking for what values of x make the y value 0, negative 1 and 2. Now, in this one here, it might be helpful. You might need to check this. 3 minus negative 1 is equal to negative 1 minus 1. Well, negative 1 minus 1 is negative 2. And the calculator, second square root 3 minus negative 1 is 2. So is 2 equal to negative 2? No, that's not true. So s equals negative 1 does not work. On the right-hand side, 2 minus 1 is 1. On the other side, square root of 3 minus 2 is 1. 1 is indeed equal to 1, so s is equal to 2. Questions on 50? Questions on 51? Do we want to look at it? Okay. 51, there's one radical, so we need to get it by itself, yes? And add 4, we would. Because the 4 and the radical are being multiplied, so we would have to divide. So we're going to do subtract 19 first. Now that'll give us negative 4 square root of 3x minus 11 is equal to negative 8. Yes? Now we said radicals can't equal an... Thank you. That an even root, so square roots can't equal a negative number, yes? Although it's the radical by itself. Now, what would we need to divide, not by just 4, but negative 4, because it's being multiplied by negative 4. We're going to divide both sides by negative 4. So the left-hand side is going to be the square root of 3x minus 11. Negative 8 divided by negative 4 is 2. So our square root is now equal to a positive number, positive 2. Yes. Yeah, negative 4 divided by negative 4. Anything divided by itself is 1. So yes, it did indeed simplify out. So it tells us 3x minus 11 is equal to 4. So even though at one point in this equation the even root was equal to a negative, but it was a negative equal to a negative, it became positive. 3x equals 15. X equals 5. Now we can check this here. Let me move all this out of the way. 19 minus 4 times the square root of 3 times 5 minus 11 is equal to 11. 19 minus 4 second square root 3 times 5 minus so it works. Questions on these here? We'll come back to some of the solving if we need. 58 through 60 inverses aren't going to show up on the test. But the last thing I do want to look at before we go back and look at anything else is this here. 62. We want to show or see if these two functions are inverses. This will be one of the bonus questions. And to get credit for the bonus, we need to show that f of g of x simplifies to x, and g of f of x also simplifies down to x, showing that they are indeed inverses. Now in the bonus, if you write that they are inverses, because they are going to be inverses, you won't get any points. It's all about showing that they do reduce down to x. Now the first thing we're going to do is plug x into g of x, which is just going to give us x squared plus 3 over 7. Then our next step is to plug x squared plus 3 over 7 into every x in f of x, which would be the square root of 7 times x squared plus 3 all over 7 minus 3. And now that we have it completely set up, we're just going to simplify it one part at a time. And especially the one on the test, the bonus that's asking to do this, take it one part at a time. Simplify with what will simplify as we go step by step. F of x. Because we're plugging in, we're taking f of x squared plus 3 over 7. So every x in f of x, we plug it in. Yeah, it looks a little more complicated than the ones we did yesterday, because there is a little more to it, but they are the exact same process. Now at this point here, since we're multiplying 7 by this entire fraction, the 7 and 7 will cancel out, leaving us with x squared plus 3 minus 3. Now at this point, the square root and x squared plus 3 minus 3 won't cancel, but 3 minus 3 is 0, leaving us with the square root of, now the radical will simplify, leaving us with x. So no matter how complicated these look, if you take it one piece at a time, what simplifies and start simplifying down, everything will start coming undone. So that's half of it. Now we're also going to do g of f of x. Now we're going to plug x into f of x, which will give us the square root of 7x minus 3. Now we're going to take g of the square root of 7x minus 3. So every x in g of x, we will plug in the square root of 7x minus 3. So our x squared becomes square root of 7x minus 3 squared plus 3 all over 7. Now since that square root, that entire square root is being squared, the square root and the square would cancel. Square root and square?
Oh, square, okay.
Yep.
Square of x.
Mm-hmm. Negative 3 plus 3 is 0, leaving us 7x over 7, which is x. So the one on the bonus, you will get down to x for both of them. But it's just working your way down to it. Mm-hmm.
I never do it. I don't know what to do.
Because it is like this, there is a lot more steps to them, but it is the same thing. We're just simplifying part by part. Mm-hmm. It might take up the whole page for both of them, but it's just writing it out. Are there any other questions over the solving? Okay. If there's no other questions on any of the